Okay, we're in week 8, and we're going to be covering the material in week 8. Again, just to remind you how this is going to go. We're going to give you like a lecture. And what's that mean? We're going to talk about the material, and we're going to introduce certain concepts. And then we're going to go through examples. The point of this is that you need to go back and review the material that we present to you, including the examples, and then do the supplemental exercises on your own. You need to exercise. And after all that's done, then you do the WebAssign, all right? Not the other way around. So don't change yourself in education. Try to listen to lecture, follow the examples, study the material, do problems on your own, and then do the WebAssign. And if you do it in that order, hopefully things will seem a lot clearer as you move along in the course, not just here, but in any other course you're taking. All right. So what are we going to do? We're doing rational functions now. What are they going to be? A ratio of polynomials. We'll go to the whiteboard later. We're going to be talking about concepts that are new to you, that were not discussed in Math 100. For example, by the way, rational functions were discussed in Math 100, but we'll be talking about vertical asymptotes. We'll be talking about concepts like limits and approaching things from the left and the right. But again, we'll go through that. Certainly, we'll talk through it, but we'll also do examples to hammer that across. We'll talk about horizontal asymptotes. That's when we go towards the infinities. Again, we're going to use a limit notation for that, but we'll talk through it. All right. We'll talk about oblique asymptotes. We'll talk about when that occurs and how you get them. All right. Oblique means they're not horizontal or vertical. They have a slope to it. All right. So next thing up is an overview of what we're going to graph out. We'll do some simple examples for you, and we'll go through those examples. All right. It's going to take some time. We provide good pictures for you. The reason for we want you to look at these things, carefully looking at these things. It's not like you can scratch work at someone at a whiteboard or a blackboard. You've got good pictures that you should be working with, and I'll talk through those, by the way. And then there's going to be another example, I believe. Yeah, second view, and we'll go through that one as well. After we do that, I know it seems like long and tedious. We'll go through example questions. I'm going to switch to the whiteboard, and as I do that, again, we'll just talk through the notes, and I'll do some work at the whiteboard. So give me 1 second to do another share with you. All right, we're on the whiteboard, and I'll start talking about it, one step at a time. And we're going to start talking about rational functions. So give me 1 moment, and give me a second here. And what I want to do is I want to talk about, rational functions. And, rational functions, whoops, sorry about that. Okay, so is the definition of rational function? A rational function is any function which can be defined as a ratio of polynomials. Well, that's interesting. Typically we're going to have like something that's really manageable on top, some polynomial that's manageable on top. When I say manageable, typically factorable, right? This is important, right? It may not be factorable, but typically factorable, all right? And the denominator, all right, also really kind of simple, typically factorable, all right, or easy to understand, all right? So I'm going to say f of x now is our rational function. What is the ratio of? 2 polynomials. Polynomials here are going to be p of x and q of x. Okay, next up. And again, as we talk through these things, this is new material for you, but rational functions are not new. But the concept of a vertical asymptote is new. And what I'm going to claim over here, vertical asymptote to me, right? If someone said that to me, I'm going to say it's basically here, it's going to be what's known as a vertical line. All right. And I put a dashed line down for a reason, because asymptotes typically written down with that dashed line. So I'm going to read this to you. And certainly as I'm reading things to you, we certainly want to encourage you to read as well. But it says the line x equals a is a vertical asymptote for the graph of f of x. What are we talking about up here? This graph over here. If as x approaches a, it's always a tough concept, by the way. I'm going to write this on the side for you. This is x equals a. Right? That's a vertical line. Let's keep moving forward in the reading department. Okay. As x approaches a through values from the left, well, that's interesting, and right of a. I want to point out what that means to me. When I'm reading that, I'm trying to understand that, this is a here. And what we're doing is we're coming in from the left of A and we're coming in from the right of A. So let me write this down for you. This is the left and this is the right. All right. We have notation for that. And I want to write that down for you. So the right side of A, we actually write the letter A down for A, and we use a plus sign as superscript. That's read as the right of A. Now, certainly if you saw that notation, say, well, gee, I think I can figure out the other one. If you're at the left of A, we put the superscript minus. They have nothing to do with negative or positive numbers. They're just left and right of A. All right. So I'm going to keep reading it. All right. So it's over here. It says, values from the left and right, f of x grows without bound. Now, by the way, when it says it grows without bound, I want to tell you what it's doing. It's either going straight up as it approaches, straight down possibly as it approaches, straight up, or straight down. All right, that's all that means. Straight up, straight down, that's all it means. Again, I'm not saying we know what they are yet, but we'll be able to figure this out pretty readily. All right. We initially do this by looking at the graph. So if you're looking at the graph, we'll talk about it. We'll look at graphs and we'll talk through it. But what we have to get to is something a little bit more complicated. All right. And we're going to typically do this business over here. So someone says, what is this thing over here? This is limit. And I want to read them to you. The first one here, this one right over here, is read as the limit as x approaches a from the right side of the function f of x. Well, like we said, it's either plus or minus infinity. What's the second one read as? It's read as the limit as x approaches a from the left of f of x. Again, it's either plus or minus infinity. It can't be both, by the way. You can't go up and down at the same time. Got to be one or the other. We'll figure it out. All right, as we start doing an example. All right, so the next one, horizontal asymptotes, generally speaking, much, much, much easier to do. Whoops, sorry about that. I really mean that. It's much easier to do. It says align y equals a. And write down what I mean by that. If y equals a, it looks like this over here. That's a horizontal line, by the way. Let me go back to reading it, and we'll say the line y equals a horizontal of the graph of x if as x approaches plus or minus infinity, f of x approaches a. Let me tell you what that looks like to me. Right. So if we want to infinity, I want to put infinities in this direction over here. Whatever the graph is doing, it's going to go towards that line. Now, what are the bigger issue is, how does it go towards that line? I'm not too concerned about that, but it could either be from above it or below it as we go towards the infinity. If you go towards minus infinity, and put this over here, this is plus infinity. If you go towards minus infinity, this is minus infinity. What am I saying? The graph is going to approach the line. Now, whether what does it from above or below doesn't matter to me. I'm just going to say it approaches the line at that point. All right, I should say at that point, that concept. All right, how do we write that down? Well, I'll go through it with you. And what are we doing over here? We're doing this business here. Whoops. I'll read it to you. The first one says the limit as x approaches infinity of f of x equals a. That means it's asymptotic to a. The next one says the limit as x approaches minus infinity f of x equals a. That means it's asymptotic with a. Let's go to the next page. And we'll talk about oblique. All right, third type of asymptote we're going to say. Oblique. It says an oblique asymptote will be the form, wow, we've seen that before. What's that going to be? It's a form of a line. I want to point out, depending on what the slope is, like for example, if m is positive, whoops, I don't mean to do that. I know I do that. If m is greater than 0, we'd have a line that looks like this. If m were less than 0, we'd have a line that looks like this over here. So that's oblique. We know what the oblique asymptotes look like now. Now, I'm going to say, this is typical, but not always. Depending on what I'm looking at. Typical, but not always. Now, must be typical, not always. If the degree of the numerator is 1 more than the degree of the denominator. But this isn't always the case. I'm just going to say, generally speaking, it's the case. What do we normally want you to do? Well, we want you to look at the ratio. If the degree of P is 1 more than Q, we would do a long division and we would get this business over here. I want to point out what these things mean to me. All right, I'll write this down for you. This is the oblique asymptote. What's the thing that remains there? It's the remainder divided by that Q of X problem. All right. So someone says, could you continue to divide? You could, but we don't do it at the math 119 level. All right. So basically, all I have to do is long division. When would I do long division? If the degree at the top is 1 more than the degree of the bottom, then I'll do my long division. Does that guarantee a slant asymptote? No. But I'm still going to be doing it. And we'll talk through examples as we do that. All right, let's go through an overview. I know it's difficult, but this is an overview. We will do more examples as time moves on. So let's talk about the overview of the problem now. So I'm looking at this, and this is an overview. What does it mean? This is the approach we're going to be taking. So we're going to be dealing with a ratio of polynomials and their graphs. Our goal is to get to a graph. That's our goal. Initially, we're going to be talking through with a picture, but our goal is to get a graph. Our graphs never look perfect, but they're enough for us to do some analysis. All right. Now, I'm always saying, please be careful of division by 0. This is like the main issue of the problem. All right. But I'll be honest with you, we like to get close to the 0. It's really the danger thing we're going to do. And we do that a lot in mathematics. We move towards those dangerous areas because interesting things happen. And we're going to see, weird behavior when we get close to those division 0. And that's the asymptotic behavior we're talking about. All right, we're going to look for that. All right. Now, certain thing I would say is, these are going to be more difficult to do than polynomials, but they're still the same type of problem. They just have more analysis in it. And that's what we're trying to get to. All right. I'm going to claim over here, again, if you're looking at my notes, little tiny embedded videos, if you want to watch those videos. But here's the deal. And I'm going to go through the deal with you over here. You're going to be given a ratio of polynomials, all right, every single time for the section here anyway, f of x. There's a polynomial on top. This is a degree 2 polynomial. And the polynomial on the bottom is also degree 2. All right. What we recommend you do is to factor the top. Let me go through that just to check it out. 2x times x is 2x squared, work beautifully. Then you get 8x minus 1x, which is 7x. That worked beautifully. And you do get minus 4. And you're going to factor the bottom. And what do you get when you factor the bottom? Well, x times x is x squared. 2 minus 1 is 1x. And you do get minus 2. It worked out beautifully. So what I'm going to do now is answer the questions. And we'll look at the picture later. All right, first question. What's the y-intercept? This is the easiest thing you could possibly do. How do you do that? All you have to do is set x equal to 0, and that's going to give you a point. If you went back up here and you set x to be equal to 0, you would get minus 4 on top, minus 2 on bottom. Minus 4 divided by minus 2 is the number 2. That couldn't have been easier. That's something that's going to be really important to do. Let's do the next one, and we'll talk about the answers on the next page when we get there. Next one says x-intercepts. All you have to do to do this one over here, all you have to do is set the function equal to 0. Let me write that down. Set the function equal to 0. Well, I'm going to say, if I were to do that, I would actually prefer the factored form of it. And I'll write that down for you. This is something you've actually done in Math 100, by the way. And certainly it's easy to do, right? So I'm going to say it's really easy to do. So what would you get over there? If you set the function equal to 0, it's like saying y is equal to 0. Now, what xi would make it 0? I want to point out to you. Well, the only xi that would make this equal to 0 is if the top becomes 0. And the top becomes 0 when x is minus 4, provided the bottom is not simultaneously 0. And at minus 4, the bottom is not 0. So I got one x-intercept now. And what's it going to be? Minus 4, comma 0. Now there's another one. What's the other one going to be? When does 2x minus 1 become 0 when x is a half? Right, and go to the next page. Keep this in mind. We're looking for these answers on the next page. 3 answers, by the way, 3 points. All right. And I'm going to point out the 3 points for you now. Ready? Okay. We found this. And what's that? That is an x-intercept. We also found another x-intercept, which is 1/2 0. Let me go back and I'll point out what I just did over there. I said I found that guy, and I just put them down on my picture. We're trying to learn. What else did I find on the prior page? I found a y-intercept. And what I say? 0, 2. It's right here. All right, so someone says you found 3 lousy points, and you're right about that. That's all I found. Now what I want to do is I want to look for the horizontal asymptote. I'm going to go back and I'm going to copy the problem. I'm going to put this down for you. I'm going to talk about what we want you to do. Copy it. Give me 1 second. Next page. And paste it in. Sorry about that. I got to do something. I'm going to talk through it now. All right. We're going to be looking for what's called a horizontal asymptote. As I do this, you may have to go back and study what we presented to you. You may not remember what we're presenting to you. But to get a horizontal asymptote, what I'm looking at is a limit problem. And I'll write this down for you. The limit, that's abbreviated LAM, as x goes towards infinity. And we're going to look at the limit as x goes towards minus infinity. Now, my recommendation to you is this. You are going to look at the ratio of polynomials. My recommendation to you is this. Divide both the top and the bottom by the highest degree variable. What's that? X squared. I want to go through that with you. What's 2x squared divided by x squared? 2 plus. What's 7x divided by x squared? 7 over x. What's minus 4 divided by x squared? 4 over x squared. Let's go to the bottom. What's x squared divided by x squared? 1. What's x divided by x squared? 1 over x. What's 2 divided by x squared? 2 over x squared. Now, by the way, I did it for that one. I do it for the next one, but I'm not going to read that again to you. I'm just going to copy. Now, someone says it's made it much worse for me. It's not supposed to be worse. It's supposed to be easier for you. And I want to point out what I mean by this. If x is going towards infinity, what do you have over here? Well, you still have 2, but you have these terms over here that involve an x. So what's 7 divided by a very large number? I'll write it down for you. 7 divided by a very large number goes to 0 incredibly quickly. And 4 divided by an incredibly large number squared goes to 0 very quickly. This one also goes to 0 quickly, and so does this one. So what are you left off with? Something really simple. You left off with 2 over 1, which is 2. Let's do the other one, a little more difficult. What am I going to say? Minus infinity? Well, you know what? It's not much more difficult because you're taking the number 7 and dividing by an incredibly large negative number. It's still going to go to 0. This is going to go to 0. This is going to go to 0. And this is going to go to 0. All right. What do you get over there? 2 divided by 1, which is 2. What does this tell me? We have a horizontal asymptote. What's a horizontal equation look like? Y equals 2. Let's look at our answer key. I'm certainly seeing it. And they say the horizontal asymptote is 2, is y equals 2. I'm going to look at my picture, though. I'm going to point out what it is. It's this thing over here, y equals 2. I want to emphasize, I'm also going to start looking at the graph now. And what does it say? It says, as you go towards infinity, the graph will go towards 2. I'm seeing it. As you go towards minus infinity, the graph will go towards 2. That's what it says. Let's keep reading. What's the equation of the vertical asymptotes? Well, I've got issues with this, and I want to point out what the issues are. A lot of students struggle with this. So what I want to do is I want to go through sign analysis of the function f of x. And I'm looking at it. It's right over here. How would I do that? If you remember what we did in the beginning of the semester, we look for the zeros. And I'm going to start writing them down for you now. And where the zero is going to be, well, looking at the bottom, 1 would make it 0. That's where it changes sign. And -2 would make the bottom 0. Now, when does the top become 0? At -4. You know what? I gotta erase it because I realize it's going to get really crazy looking if I don't. Let me do that again. I'm sorry about that. -4 on top. All right. That's where this factor becomes 0. -2 on the bottom. I'll write that down for you. That's where the other factor. And then what do I get? I'm going to say, well, another one on bottom would be 1, right? Put it over here. Whoops, sorry about that. And what's the other one going to be? Well, if you look at it, that would be a half, right? Now, where's a half? Right over here. I got to get black to black. I realize for some students, this is just too much for me to do. I can't do all that work. You got to start learning to do the work. All right. So what I want to do is I want to start talking test points here. And someone says, I wonder what test points you're going to choose. I'm going to choose what I find to be easy. And again, your mileage may vary. 2 -3, 0, -5. What's a good number over there? And I know this is tough. 1/2 is about 0.5, not bad. It is 0.5, and 1 is 1. So I'm going to say 0.7. What am I going to do? I'm going to try it. Someone says, where do you try it? I try it here. I'm doing sign analysis. Easy peasy, lemon squeezy. Plug the 2 in on the top. What do you get? Positive times a positive. What do you get in bottom? Positive times a positive. Positive. All right. Now I'm going to take the 0. Someone says, why is that? 0.7 scares me. You put 0, what do you get on top? Negative number on top. What do you get on bottom? A negative number on bottom. What is a negative divided by negative? Positive. All right. Let's try -5. What do you get on top? A negative times a negative, which is a positive. What do you get on bottom? A negative times a negative, which is a positive. Everything's positive. Let's try -3. Again, if you're struggling with this, you're really back in chapter 1. What do you get there? Negative times a positive. It's negative on top. What do you get on bottom? Negative times a negative, which is positive. Overall, it's going to be negative. All right, let's do 0.7. What do you get on top? Well, 1.4 minus 1 is positive. 0.7 plus 4 is positive. It's positive on top. On bottom, it's negative. Overall, it's negative. All right. So why would you go through all that work? Well, I'm going to say when you move on, you don't need to do all that work. What I'm going to claim over here is the reason for doing that work. I need to discover something about the limits in the problem. And what I'm going to do is talk about that limit now. And we'll go to the next page later. And I want to tell you what the limits are going to be. I'm going to be looking at the limit, and I'll write this over here for you. I'll write this very carefully down for you. The limit as x approaches the incredibly dangerous numbers, and there's 2 of them. One of the numbers is the number 1, but I can approach the 1 from either the left or the right. Now I'm just going to write f of x over here. I'm going to write f of x over here. We'll do that later. Now someone says, if 1 is dangerous, what's the other dangerous number to approach? Well, the other dangerous number to approach is actually the number -2. From the left and from the right. Okay, I just want to do sign first. That's why I did sign analysis. So I'm going to start pointing things out over here. 1 from the left. 1 from the left, what is it? It's a negative number. Let's do the next one. 1 from the right, 1 from the right. What kind of number is it? It's a positive number. Let's keep going. -2 from the left. What kind of number is it? It's a negative number. Let's do the next one. -2 from the right. What kind of number is it? Positive number. I'll put that down for you. I gotta be honest with you, these are going to be incredibly easy to do if you understand what happens. All right. And I want to point out what I mean by that. I'm looking at this. I can't emphasize that enough times. And what I'm really worried about is, what do we have? We know the signs of these things, but my question is, what happens to the bottom in every single case? In every single case, the bottom will become 0. So then you got to start thinking to yourself, if the bottom is 0, what's going to happen? Well, the top is some non-zero number. The top is some non-zero number over here. So a non-zero number. But the bottom is getting really close to 0. What's going to happen? Every single time, it's going to blow up. This is an indication of asymptotic behavior. And let's write this down now. And what's this going to imply over here? That we have an asymptote x equals 1. And this is going to imply that we have an asymptote of -2. Let me go to the graph. As I do that, we're going to talk through it. All right. So I'm going to say, I want to see, do I see x equals 1? And I'll write this down for you. I definitely see it. It's right over here. X equals 1. Do I see the other one? Of course I do. What do I see? X equals -2. I see both of them. Let me go back over here. I want to repeat to you. This is important. We're going to do one at a time. If you approach 1 from the left, it goes to -infinity. Let me do that. 1 from the left. This is the left side. What did it say it's going to do? Go towards -infinity. I want to draw that in for you now. All right, go back. If you approach 1 from the right, it will go to +infinity. Let me see if that's true. Oh boy, I'm messing up. I really apologize for that. I got to clean that up a little tiny bit. I don't know what happened there. Let me just see. I got to really, you know what I'm going to do? I'll just go backwards. All right, sorry, I really screwed up there. So let me just go back over that. I got to be really careful when I pull this thing around. And I'm looking at this over here. So if you go 1 to right, it goes +infinity. Well, you know what? I want to see if I can do that. I did it again. Let me see if I can do this. Yeah. Okay, let me point out what I just said. 1 from the right side, +infinity. I'll trace that in for you. All right. But I'm not saying we're done with this. I want to go to the -2 though. And -2 from the left is -infinity. -2 from the left, that's the left, right? -infinity. Put that down for you. Oh boy, I did it again. -2 from the right, +infinity. All right, my claim is this. Right now, I have enough information to connect it together. And what do I see? Yes, I know the graph is there. There's got to be a connection like this. And there has to be a connection like this. Between these connections to the first point, then to this point, and then to that behavior. How about this over here? Something like this might be reasonable. We got our entire picture, entire picture. So what I want to do is make sure you know that all this stuff is written down for you, and we spoke you through that. I'm not going to say you know how to do this yet, but we're going to do other examples. And by the way, last but not least, they do ask about the domain of it. I see that there, and the range of it. Domain is fairly easy, and I want to point out why that is. It's, if you look back at the original function, I can't divide by 0. So I'm going to just simply say all real numbers. And where was the division by 0? At -2 and at 1. If you want to write down the interval notation, it could be minus infinity up to -2, union -2 up to 1, union 2 to infinity. Let me go back to the picture, and this is the picture over here. Definitely got the domain down. All right, let me point out what I mean by that. Minus infinity up to -2, it didn't hit it. Then it goes from -2 up to 1, doesn't hit it. Then it goes from 1 to infinity. The other question is range. Range, I want to be honest with you, look at the picture, and what do I see? Everything is being covered, everything. Now, I probably wouldn't have known that unless I looked at a picture. So we go next page, and we'll talk about the range now. What's the range going to be? All real, sorry about that. All real numbers. You can use the Blackboard R or the notation, interval notation. I actually prefer interval notation. All right, let's do second view. And the second view is this guy over here. So as I'm doing this one over here, what I'm claiming over here is I really want to look at what they have written down and understand where it's coming from. This is a rational function. It's a ratio of 2 polynomials. What did they do? They factored the top. The bottom's really already factored. It's a factor of x minus 3. But let's see if the top is done correctly. What do you get? X squared minus 5 plus 1 is minus 4x. Yeah, it looks good. But what else did they do? They did a long division. Now, why would they do a long division? Because the degree of the top is 1 more than the degree of the bottom. I'm going to go through that with you now. All right. So when I do that, I want to point out what the long division is going to be. The long division is going to be x minus 3 is going to be divided into x squared minus 4x minus 5. If you need help with long division, you're really going back to math, trying to relearn that material. So what times x gives you x squared? X. What do you get there? X squared minus 3x. What do you do now? Subtract. That'll be minus x minus 5. What do you get down? Minus 1. Why is that? Minus 1 times x is minus x. Then what do you get? Plus 3. You subtract, you get minus 8. So what am I going to say over here? F of x. Well, what did I find out? I found that as x minus 1 plus, I didn't finish. What didn't I finish? I didn't finish dividing minus 8 by x minus 3. Believe it or not, that can be done, but we don't do it at the Math 119 level. The other way of writing this down is simply saying x minus 1 minus 8 over x minus 3. But both are acceptable answers, by the way. What do they have over here? This over here. This is important. You want to be able to rewrite them, factor them, and do long division if necessary, because it's going to help me greatly in the analysis. I also want to point out, if you're reading the notes, and we hope you are reading these notes, they do give you images, and those images are clearly specified over here. Red things are linked. You click on those and we right to the image. Let's do first question. What's the first question? What is the y-intercept? Well, that couldn't get any easier. All you have to do is set x to be equal to 0. And this will give you a point. When x is 0, let's go through that. What would you get over here? 0, 0, minus 5. That's not bad. You get minus 3 in the bottom. So what's minus 5 divided by minus 3? It's 5/3. That was easy. I like easy things. Let's go to the next page. Well, I see that. I want to see if I see it on my graph, though. By the way, I hope you're looking at that and you realize that's, if you looked at it, it's 1/3 of the way up to 5/3, which is 5/3. That worked out beautifully. No problem there. All right. Now I got to go to the next question. The next question, I remember the function. I'm gonna copy it. All right, I'm gonna copy this. I'm just gonna paste it. Whoops, sorry about that. Push that over here. Don't be alarmed. And they want to know the x-intercept. So someone says, how would you do that? Well, I can't emphasize enough times. You're just going to simply set the function equal to 0. I'll put that down for you. So that's going to be f of x equal to 0. That's like saying y is equal to 0. And what do you get over there? Well, if y is equal to 0, what am I basically saying is, I'm saying that this factored form is equal to 0. And when would that occur? Well, it's only if the top becomes 0, provided the bottom is not simultaneously 0. And that would occur at -1, and it would occur at 5. Now, I want to look at my answer key because we want you to do that too and see if that's what they said. And that's what they said. Now, let's look at the graph, by the way. And when I look at the graph, I really want to look at the graph. I want to see if I see those things. And I'm going to say, I definitely see the 5, 0. It's right here. And I'm definitely seeing the -1, 0. That's done. I got that covered. All right. Now, suppose you got 3 lousy points. You're not kidding. There's only 3. Next one up. The equation of the vertical asymptote. That's going to be more difficult. All right. So what am I going to do? I'm going to do sign analysis for you. And let's put this down. It's really important you get this down. So what's sign analysis? I look for the zeros at the top, and that would occur at -1 and at 5. And the 0 at the bottom would be 3. Okay, that didn't come out so nice, did it? Okay, I'm going to take test points now. And let's take a look at this. I'd say 6 here. I'd say 4 here. I'd say 0 here. And I'd say -2 here. Just doing sign analysis, see how this thing looks like. And suppose it's necessary, it's necessary. All right, at least initially it's necessary. You'll get better over time. So if you put 6 in at the top, what would you get? You get a positive times a positive, and a bottom you get positive. So everything is positive. If you put 4 on top, what would you get? You get a negative number, and on bottom you get positive. So overall it's negative. Now, if you put 0 on top, what do you get? You get negative, and what do you get on bottom? Negative. What's a negative by negative? Positive. It's really important. If you put -2 on the top, what do you get? A negative times a negative, which is a positive, and on bottom you get a negative. Overall, it's negative. All right. So someone says, why would you have gone through that trouble? I at least know the curve is positive after 5. It's negative between 3 and 5. It's positive between -1 and 3. And it's negative below -1. And that's really nice to know. What do I want to do, though? I want to get the vertical asymptotes. And let's write this down. How do I do that? It's a limit problem. Limit as x approaches the dangerous number, which is 3. There's only one of them. It's on the bottom, from the left of the function f of x. And I want to do the limit as x approaches 3 from the right of f of x. Here's the deal. I'm looking at it, and I think I know sign right now. So I want to point out what I got. 3 from the left. 3 from the left. What is it? It's a positive number. I'll write that down for you. What's the next one going to be? 3 from the right. 3 from the right. What kind of a number is it? Negative number. I hope you realize what happens when we touch a 3. The bottom becomes 0, and the top is some finite number. This is going to blow up without bound. It's infinite. What does this tell me? I have a vertical asymptote at x equals 3. Let's go back to the picture and show you that. This here is the line x equals 3. All right, let's take a look at our work. And we got this covered over here. We did a good job. We got it. All right. Let's go to the next page. I think there's going to be some questions over there. We'll come back to this. Someone says, what do you have down here? I have 3 lousy points. That's it. 1 asymptote. Let's go to the next page. What's the next page? Equation of the slant asymptote. Well, you know what? That couldn't get any easier. I'll tell you why. It's right, and I'll circle this for you. It's right here. What's that going to be? Y equals x minus 1. Let me go back over here. And I'm going to go that. I'm going to write the answer down. And what's the answer going to be? Y equals x minus 1. What answer do they have down? Same answer. Let's go back to our picture. What's the slant asymptote? Y equals x minus 1. That's a line. What kind of line is that? A line with slope 1 and a y-intercept of minus 1. I clearly see that line drawn there. Clear as day. All right. Now, someone's going to say, what are you going to do now? I am going to talk about the asymptotic behavior. As you go towards infinity, it'll approach that line. As you go towards minus infinity, it'll approach that line. As you approach the vertical asymptote, oh, I don't remember that. We'll take a look at it. And I'll point out what I'm talking about. As we approach 3 from the left side, it goes to plus infinity. Give me 1 second here. Again, 3 from the left side, plus infinity. Let me follow me. 3 from the left side, plus infinity. I'll draw that in for you. Don't worry, we'll connect it up together later. 3 from the right side, minus infinity. 3 from the right side, minus infinity. Someone says, could you connect it together? Well, you know, I do see the picture. I know that, but I think for the most part, you got a good idea. It's got to hit that point, then this point, and this one over here. This one over here, got to hit that point, and then it's got to go toward that behavior. And I'm done. All right. Again, the pictures are there to help you. Eventually, the pictures will be taken from you, though. All right. Let's go to the next page, see if we've done that. Oh, the domain of it, I got to go back and look at the function. The domain is all real numbers except 3. I'll write that down for you. So all real numbers, it can't be 3. If you wrote this down in integral notation, it'd be minus infinity to 3 union 3 to infinity. What's the next question? What's the range? Look at the picture. I want to claim, looking at the picture, everything is being covered. Just look at these curves over here. Everything is being covered. So all real numbers. How would you write that down? A Blackboard R. If you want to write down integral notations, minus infinity to infinity. And again, these answers are listed for you. All right. So next up, we finished lecture. I realize it's tough. We need to reinforce this over here. Here's the deal, though. You've got to study. You've got to study. This stuff doesn't come quickly to a lot of students. It comes slowly, but it does require work. And the more work you put in, the better it gets for you. All right. So I'm going to say examples next.